The better parts of the world for insolation, we will talk a lot about the word insolation later in the lecture, but right now it's the amount of solar power received from the sun. Right now, top level description, insolation is the amount of solar power received from the sun. So the better parts of the world for insolation receive an average of around 250 watts per square meter. That's a very general figure, and it's 365 days per year. So every single day, every single square meter on Earth, on the average, receives 250 watts coming from the sun. Simple calculation. 250 times 24 hours a day times 365 days a year divided by 1000 in order to make it a kilowatts, because 250 is watts, equals to 2190 kilowatts hours per square meter per year. That's the total insolation, solar radiation on square meter per year. So if I want to look at 1 square kilometer, okay, it will receive around 2190 times 1000 times 1000, in order to convert it from meters to kilometers, 2.19 billion kilowatts hours per year. Let's continue. So in the year 2030, remember, the world consumption will be 33 trillion kilowatts hours. If we divide it into 2.19 billion, we basically will need 15,000 square kilometers of panels, PV panels. And that's for 2030. Let's look at what is basically the 15,000 kilometers. We see really not the final number. Let's see. If the efficiency was 100%, then really we would need 15,000 kilometers, but the efficiency is not. Kind of a general figure, we look at 15% efficiency for the PV industry. A PV cell, 15% efficiency. 85 is being lost, is not converted to electricity, 15% converted to electricity. So if we assume that our method of converting that energy, PV technology, is only around 15% efficiency, then instead of 15,000 kilometers, we would need 100,000 square kilometers. And this is net panel area. But a PV farm, an array, we're not looking at net, we're looking at gross area. We would need to double that to allow room for roads and other infrastructure within our solar collecting area. Therefore, from 100,000 square kilometers, let's double it, 200,000 square kilometers on Earth's surface to support a consumption of 33 trillion in year 2030.